Now we're going to look at how to find the determinant of a 3 by 3 matrix. I will briefly talk about larger matrices, but that's going to be something that you'll generally encounter in linear algebra. Right now, the focus is going to be on 3 by 3s. So here we want the determinant of this matrix A, and so we can write this with vertical bars and elements 2, 3, 1, 0, 2, 4, -2, 5, and 6. And the way that we deal with finding the determinant of a 3 by 3 matrix actually involves looking at determinants of 2 by 2 matrices. So what we're going to do is we're going to look at first the elements in the first row. And these elements are 2, 3, and 1. And what we're going to do is we're going to look at each of these elements and then also the matrix that's formed when we get rid of the row and column that that element is in. So first, let's take a look at 2. This is the first element in the first row. And what we want is we want to look at the matrix that we would have if we deleted the row and the column that 2 was in. So if we got rid of this row and if we got rid of that column, we would be left with the matrix with elements 2, 4, 5, and 6. And we're going to take the determinant of that, and it's going to be multiplied by 2. Then we're going to take the next element in the first row, 3, and we're going to multiply it by the determinant of the matrix that we would have if we got rid of the row and the column that 3 is in. So if we did that, we would be left with 0, 4, -2, and 6. And then finally, we're going to look at the last element in that first row, 1, and we're going to look at the matrix we would get if we deleted the row and column that the 1 was in, and that leaves these 4 numbers down here, 0, 2, -2, and 5. And so each one of these is getting multiplied by the matrix we would get if we deleted the row and column. So with 2, if we delete the row and column, we're left with these 4 numbers. So with 3, if we deleted that row and column, we would be left with these 4. And then with 1, if we deleted that row and that column, we would be left with these 4. So, one more thing. I didn't put additions and subtractions in between these because we're always going to have the first one being positive, the next one being negative, so we're going to have a -3 times the rest of it. And then the third one is going to be added to it, so +1. And if this was a 4 by 4 matrix, it would be positive, negative, positive, negative. If it was a 5 by 5, it'd be positive, negative, positive, negative, positive, etc. And if we had a bigger matrix, like a 5 by 5, then when we deleted a row and a column, we would end up with a 4 by 4 here. And we'd have to go through the process again of deleting rows and columns to get 3 by 3s and 2 by 2s. And it ends up being very, very complicated. So just for right now, we're going to focus on 3 by 3 matrices. At this point, we've rewritten this determinant in terms of determinants of 2 by 2 matrices, and we should be able to go through and do the math. So we've got 2 times the determinant of this matrix, which we get by taking 2 times 6, which is 12, minus 4 times 5, which is 20. Then we've got -3 times the determinant of this matrix. 0 times 6 is 0, minus 2 times 4 is -8. And then lastly, +1 times the determinant of this matrix. 0 times 5 is 0, minus -2 times 2 is -4. and then we can go and do the math inside the parentheses. 12 minus 20 is -8. 0 minus -8 is 0 plus 8, which is 8. And 0 minus -4 is the same as 0 plus 4, which is 4. Then we can do the multiplications. This gives us -16 minus 24 plus 4. -16 minus 24 is -40, and -40 plus 4 is -36. So the determinant of this 3 by 3 matrix is -36. It is a lot of work, and it probably seems very weird and arbitrary that we've defined this determinant based on smaller determinants and we're adding and subtracting and things like that. But this ends up having a lot of uses. We will see one example of an application of determinants in the next video, but some of them you won't see until you get to Calc 3 or linear algebra. In fact, one of the reasons that we're looking at matrices and determinants now is to make things just a little bit easier when you see them in Calc 3 and linear algebra. Because when it's the first time you see something, it's generally a little bit confusing, but at that point it will have been your second and third times seeing determinants, and so that'll make it a little bit easier at that point to look at the applications.